We'll take few examples. Let us take, okay, I'll write down that find CTFT of x1 of t, which is equal to x of t minus t naught. So we will use convolution in time domain property to find the Fourier transform of this signal. Okay, yes. So we know that shifting operation is what it is. It can be written in terms of convolution operation. How we know that x1 of t, which is equal to x of t minus t naught, is equal to how much? X of t convolved with delta of t minus t naught. So this we have already seen in second chapter, right? LTI system. So we can write the original signal x1 of t, which is x of t minus t naught, as convolution operation. Okay, now let us write down step by step. So x of t has what as Fourier transform? It has x of j omega as the Fourier transform. Similarly, delta of t minus t naught will have what as Fourier transform? Time shifting property. So that will be 1. Delta of t has 1. So delta of t minus t naught will have 1 into e power minus j omega t naught as the Fourier transform. Now let us write down x1 of t, which is equal to x of t convolved with delta of t minus t naught. So this fellow will have what as Fourier transform here? You are convolving in time domain. So what should happen? In frequency domain, the corresponding Fourier transforms should get multiplied. So you will get x1 of j omega, which is equal to x of j omega multiplied with e power minus j omega t naught. So something should strike, correct? So what is this? So this is nothing but shifting of a signal x of t by t naught units, and hence you get x of j omega multiplied with e power minus j omega t naught, correct? So this is equal to how much? That is equal to x of t minus t naught. So that fellow will have x of j omega multiplied with e power minus j omega t naught as the Fourier transform. Okay, so we'll take one more example, which is little bit important. Okay, so what does this say? Let x of t equal to e power minus at u of t, comma h of t equal to e power minus bt u of t. Okay, question is evaluate y of t is equal to e power, or I'll write down y of t equal to x of t convolved with h of t. Okay, evaluate y of t equal to x of t convolved with h of t for two cases. So what is the first case? When a is not equal to b, and second case when a equal to b. So let us solve this. Okay, so clearly we have to find out the convolution between these two signals. What are they? E power minus at u of t and e power minus bt u of t. But if you do regular convolution, it will take time, and hence we will take the help of which property? Convolution in time domain is equivalent to multiplication in frequency domain. Okay, so first we will write down y of j omega. Okay, so before we go into that, so we will first concentrate on this case. What is that? A is not equal to b. So x of t equal to e power minus at u of t. So this fellow will have x of j omega, which is equal to 1 by a plus j omega as the Fourier transform. And similarly, h of t equal to e power minus bt u of t. So this fellow will have h of j omega, which is equal to how much here? 1 by b plus j omega as the Fourier transform. Now let us write down what is y of t, correct? So y of t is equal to x of t convolved with h of t. Okay, so which is equal to how much? E power minus at u of t convolved with e power minus bt u of t. So this fellow will have what as Fourier transform? This fellow will have y of j omega, which is equal to how much here? Convolution in time domain is multiplication in frequency domain. So you will get x of j omega, correct? X of j omega multiplied with h of j omega. So which would be equal to 1 by a plus j omega multiplied with h of j omega, which is 1 by b plus j omega. Okay, so we got y of j omega to be 1 by a plus j omega multiplied with 1 by b plus j omega. But what is the question? We have to find out y of t. So to find out y of t, we should take inverse Fourier transform of y of j omega. So before we do that, we will write down y of j omega to be equal to how much? 1 divided by a plus j omega multiplied with b plus j omega. Okay, now if you take partial fraction expansion, what do you get? Yes, you replace j omega with minus a, so you will get 1 divided by b minus a divided by a plus j omega as the first term. Similarly, if you replace j omega with minus b, you will get 1 by j omega is replaced with minus b, so you'll get 1 by a minus b divided by b plus j omega. Correct? You replace j omega with minus b, you will get 1 by a minus b. Okay, so we'll write down this nicely. So what do? I'll take 1 by b minus a out. Okay, if you take 1 by b minus a out, you will get 1 by a plus j omega. So you have 1 by a minus b here, but what is out here? 1 by b minus a, and hence you will get minus 1 by b plus j omega. So that would be our y of j omega. Okay, so this we got y of j omega. What is the question? We have to find out y of t. So this implies y of t to be equal to how much? We are taking inverse Fourier transform. So 1 by b minus a would be as it is. And what is inverse Fourier transform of 1 by a plus j omega? That would be e power minus a t u of t minus what is inverse Fourier transform of 1 by b plus j omega? E power minus bt u of t. Okay, so this would be the convolution of, correct, e power minus at with e power minus bt u of t. Okay, so note that we did not do any integration here. We just found the Fourier transform, we took the multiplication of the Fourier transforms, and we took the inverse Fourier transform. So that would give you the convolution of these two signals. So this is the case when a is not equal to b. What happens if a equal to b? Okay, so if a equal to b, what will happen to y of j omega here? Y of j omega would be equal to from here we get 1 by a plus j omega whole square. Correct? If a equal to b, if y of j omega would be 1 by a plus j omega whole square. But what happens to y of t? Y of t would be equal to, okay, so y of t would be equal to e power minus a t u of t convolved with e power, because a equal to b, again you will get e power minus a t u of t, and this we got the Fourier transform to be how much? 1 divided by a plus j omega whole square. But just now we have seen that in differentiation in frequency domain property, which signal will have 1 by a plus j omega whole square as the Fourier transform. Okay, so if you take inverse Fourier transform, this will give you y of t equal to how much here? T times e power minus a t u of t. You have already seen this. I said please remember, right? So t power n e power minus a t u of t will have n factorial by a plus j omega whole power n plus 1. Now n is 1 and hence you will get 1 by a plus j omega whole square. So e power minus at u of t convolved with itself will give you what as the answer, t times e power minus at u of t. So we have taken care of two cases. So let us summarize the result what we have got. It's very important result. So what is that we have got? We got that e power minus at u of t convolved with e power minus bt u of t to be how much? We got this to be if you look at the this thing, so how much is that? We can take u of t out and we can write it nicely. I'll write down here. So you will get e power minus at e power minus bt divided by b minus a, and this whole thing is multiplied with u of t, correct? U of t is out, you can take it out. So you'll get e power minus at minus e power minus bt divided by b minus a. Okay, so this is the case when a is not equal to b. So when n a equal to b, you get t times e power minus at u of t. This is the case when a equal to b. Okay.